Hello. And I may have left this one a bit too late. Well, not too late, because we're here, so it's not too late. But it's late. It's late. And, well, we're showing up. So, let's get on with it. So I guess they were looking at sort of the idea of recursion. Well, we haven't started the idea of recursion, but we're talking about how functions get executed. And when you pile them into, or when you start calling functions, they almost get executed individually. And so one on top gets executed first, and then brought into the bottom, right into the third, etc. So here we're popping off the last one. The call stack. And we did this yesterday. But yeah. So this is yeah. So while that was a simple example, oh, can you see everything? Yeah, I think you can. I have got that. Cool. It probably would be good to see how this looks actually. I've watched the videos back after the fact, but I've never seen myself live. So let's do a little bit of meta stuff here. On the one hand, because I am tired and my head is sort of warming up to the idea of getting back on this. On the other hand, I actually want to see what this looks like. So, can I find the live? Oh, I found my own live. How do I find my own live? There you go. This is going to be interesting. Okay. Oh, it doesn't look too bad, you know. Okay. So it's about 2 minutes behind. But that's crazy. That's weird. I'm going to show myself. Oh, that's going to be meta. It's actually quite cool. Yeah, the breathing be serious. So I am watching myself watch myself right now. I'm gonna do it again. Anyway, yeah, that's mad distracting. Alright, cool. Let's do this. So, the idea of sticking functions into a array and popping them off the call stack is simple, but it does demonstrate how functions get used. So we're gonna remove the array and the console. Sort everything. This should not be a step, man. Okay. So we're going to create a function that takes a number and counts down from that number to 0. Okay. Oh, this is peak. Well, I should donate as well. I want to donate. I will donate. But I think this is asking me to subscribe. How do I become a supporter? See, it's a per month thing. And I should. I'll do that later. Cool. Okay, so we're going to log the number to the console. A recursive function is a function that calls itself over and over, but you have to be careful because you can easily create an infinite loop. That's where the base case comes in. The base case is when the function stops calling itself, and it's a good idea to write it first. So this is what we're doing with the loop, where we kept on inserting sort of the last iteration of it. Now, since our countdown function will count down from a given number to 0, the base case is where the number parameter is 0. Then it should return to break out of the loop. Use an if statement to check if number is equal to 0, and if it is, use return to break out. A recursive case, which is what the function called itself, is an if else statement. Leave the body of it. Well, this is just add an else. They made that sound so technical. I turned the if statement into that. It's just add else. What is the base case? What is the least amount of work you need to do to get closer to the base case? Now, since the base case is when the number is equal to 0, you need to call countdown again while also lowering the value of number by 1. Count down and pass it the number. Okay. Let's see. Well, will it work? So okay, because it's calling itself here. Okay, so countdown number. Yeah, it will work. It should work. Oh, it's already started doing stuff. Countdown 3. Okay, yeah, it does. So recursive isn't necessarily anything else. It's just it's a function that calls itself. Sorry, I saw that as well. Oh wait, hold on, what? Okay, so we just go down. So we've just done the same thing again. We haven't actually changed anything. Oh, okay. So I called it a 4th time. Or 5 times. attention to that. Oh. Wait, what's happening? How many days did it call? Yo, okay. Another thing is, so they're more than happy here to add this to the code, just to start debugging stuff. So probably something that we shouldn't be worried about doing. Okay, so our base case. Our base case is input is very much equal to 0. Oh, sorry. If it is return, then I'm not even reading now. Return empty string. Cursive case, add an else statement, or return the result of calling. That's a problem. Oh, wait, hold on. Oh, no. Oh, okay, so no, we're not actually doing that. We're doing this. We're doing math, not floor, of input divided by 2. That's what we're doing. I think this is the answer. going to. That's not happy. I'll go back to summarize happy. That's cool. Okay. Gotta pay attention to the details, man. Ma'am. Okay, cool. So this effectively lowers the input by roughly half each time the decimals of binary function is called. However, remember that the binary number string getting text messages. Alright, I'll be right back. Yo, that was easy. One of the funniest calls I've received for no reason. Cool. So yeah, the binary number is yes. Sorry. So the binary number string gets built by calculating the remainder of input divided by 2 and concatenating that to the end. So after we call let me just let the thing know. Robert calls anyway, cool. So I remember that the binary number is string is built by concat. Yes. So after we call decimal to binary, use the addition operator to concatenate the remainder of input divided by 2 to the end of the string your recursive function returns. Also wrap the operation in parentheses. I'm confused as to how to do this. After your call to decimal to binary, use addition operator. So I'm confused as to how to do this, but what I'm going to do instead is just follow the steps. So after the call, so at this point I'm just trying to follow this step. So wait, when alright, so decimal to binary, if it's 0 will return nothing. So does return always bring back a string? Okay. At this point we're returning decimal to binary 0 plus. I don't know how this is working, honestly. I don't think I fully understand what it's doing, because if we go to our decimal to we put in 2 here. Oh wait, let's put in 0, 1, 0, 1. We're not removing the lead in 0. What's 2? What's 3? Okay, so 0, 1, 1. What's 2? 0, 1, 0 is 2. If I just put in 2, okay. So when I put 2 in here, it's not 0. So it comes down and I'm returning something else. So I put 2 divided by 2 is 1. So wait, when I put 0 in, I get 0. When I put 1, I get 0, 1. Why? Because my floor of 1 divided by 2 is, rounds it down, 0 plus 1. No, because what's the made? Okay. Cool. So we put in 1, right? Yeah, we put in 1. 1 divided by 2, my floor of that is my floor of that wait, return. When we call it, we're just doing that. Oh. And it will keep doing that. Okay. So when we put in 1 the first time, my floor of that is 0. 1 divided by 2 is 0, remainder 1. We call that again. I can't say I fully understand it yet, but that's okay. That might have to be a bit for another one. Alright, I'm gonna do this tomorrow. Peace, guys.